In this problem, helium neon laser light, which has a wavelength of 632.8 nanometers, is sent through a single slit of width 0.3 millimeters. What is the width of the central maximum on a screen 1 meter in back of the slit? So what we have for the single slit pattern is the prediction of where the dark spots are going to occur. And we know that this central bright region is going to be flanked on either side by dark spots. And this y value tells us what is the distance between the very center of the pattern and one of these dark spots. So let's look and see if we can find this dark spot, the dark spot to the right of the single slit central bright region. So if we find the location of this dark spot, that means that that dark spot is going to be equal to, well, m is equal to 1 for this first dark spot to the right of the center of the pattern, and then lambda is the wavelength. Now, since we have different lengths here, so we have, has units of length, this is the distance from the slit to the screen, so that has units of length, this has units of length. So we have all of these things with units of length. We need to make sure that all of these variables use the same units so that we don't have conflicts between units. So we need to make sure that all of these are expressed in meters. So for the wavelength, we have 632.8 nanometers, but that's the same thing as 632.8 times 10 to the minus 9 meters. And then the length is the distance between the slits and the screen, which is 1 meter. And then finally we have the slit width, and the slit width is 0.3 millimeters, so that's 0.3 times 10 to the minus 3rd meters. So that's going to give us a value for y in meters of 2.11 times 10 to the minus 3rd meters, which of course is the same thing as 2.11 millimeters. So we know there's 2.11 millimeters between the very center of the pattern and the first dark spot to the right. But what the problem is asking for is what is the width of that central maximum. So we actually need to take this value and double it, because we want actually the distance between the dark spots on either side of the central bright region, because that will give us the total width of that central bright region. So we'll want to double this value that we found, which is half of the width of that central bright region. So if we take and double that, we get a value of 4.22 millimeters, and that's the value that we want. That is the width of the central bright region.